Okay, so one of the things that we have looked at multiple times is that if our scatter plot is not straight enough, then we should not apply a linear regression to it. Unfortunately, that rather limits some of the data we would like to look at.
So what do we do?
Well,
We just do it anyway.
What do we do, Mr. Davis?
we do something called re-expression. Re-expression is the process of applying a function to the data in order to make either a scatter plot straighter and then to apply a regression model, or to make a distribution more symmetrical.
Okay.
Either one. So let's look at a couple of different cases. For example, we'll do less of this kind than we will of the other, but with this histogram, what kind of skew do we see here?
Right.
Yeah, very strong right skew. It's difficult to do much with this. We certainly couldn't apply a normal model to this, right? But one of the goals of re-expression is to make the distribution of data more symmetric.
Remember this.
Oh, I literally wrote that.
You wrote Moss instead of Moore?
Yes.
It's kind of cool.
Should this only be used when there's like outliers like that, or can you use it on like any skewed graph?
You could use it on any skewed graph. I just picked one that was crazy skewed.
Okay. Ultra.
Ultron.
When it's really, really big skewed like this, you can take the log of our explanatory variable. I still have to think about explanatory variable and responding variable. Okay, but this is our explanatory variable. If it's way spread out like this, then by taking the logarithms, now we get something that it's like, okay, I could probably find the mean and the standard deviation and talk about that reasonably. Whereas with this, our only hope is to talk about the median and to talk about the IQR, which doesn't allow us to do as many things because then we can't do z-scores, we can't do all those other things. We can't talk about, well, how unusual is this? Remember, in terms of standard deviations, what is it that we're looking for in order for something to be considered really big or really small?
2 or more.
Yeah, 2 or more standard deviations away from the mean. Okay? But we can here. And even if we had the IQR on this, the IQR, I mean, it's going to take up so much. Is there something that's really small? Well, it looks like it here that there is. It looks like there's some pays that are actually pretty small relative to the rest. Okay, you can't see that very well on this. With IQR, what do we look at for outliers?
What did you say?
When we have the median and the IQR, how do we use that to look for outliers?
1.5.
Oh, you calculate
1.5 times what?
IQR.
The IQR
From the
more than Q3 or less than Q1. Now that doesn't mean unusually small or unusually large. When they say that, they usually are talking about the 2 standard deviations, the z-scores. Okay? So this is one case. And again, we don't do a whole lot with histograms in this chapter. Primarily, we're going to be looking at trying to straighten out a data plot. Okay? But here's another case. One of the other things we might want to do is make the spread of several groups more alike. I'm sorry? Oh, exposure to smoke.
What do the stars mean?
That those are far outliers.
So what's going on with the first two?
Well, what happened is because of the scale that we had to use,
Oh, it's just really okay.
it's so compressed that there's just not much in there. So the continine is a chemical that's left over after you've been exposed to smoke. And so there's very little if you've never had exposure to smoke. But if we take the log of that, then we can see, okay, now we can compare these more easily. Okay, and there aren't as many outliers. When you have too many outliers, it's hard to make comparisons. Okay, that makes sense?
Yep.
And again, we won't be doing a whole lot of this. This is to make you aware, and I'll show you why you need to be aware in a little bit. But actually doing is like page 2. So we have the f-stop and shutter speed compared, and that's very much a curved set of data, right?
Yes.
It almost looks like a log.
Oh.
Yeah, or like a square root. But it's not quite flat enough to be a square root. But yeah, looks like a logarithm or a square root. Okay? So our goal here is to, let me put it exactly the way I put it, but it's basically to straighten it. Make the form of a scatter plot more nearly linear. So noticing here that this looks like either a logarithm or a square root, we could get rid of that. And part of the reason I immediately thought of it as a square root, because I was like, well, how am I going to get rid of that? I can square this variable. And that should undo the square rootness of it. And we get a pretty good line here.
What do you think the correlation is there?
Pretty
One
close to 1.
squared.
It seems like it would be.
That's good to hear.
Okay, and one other one that we may want to do is we want to make the scatter in a scatter plot spread out more evenly instead of thickening at one end, where you have a whole bunch. And that's part of what's happening here. Notice we have a bunch of data points here, and then we don't have very many here. We might want to take the logarithm of this, and then that would spread these out a little more evenly. So sometimes you'll do more than one thing. And it can get, honestly, it can get very complicated.
I feel like at that point the graph begins to lose some of its,
Integrity?
Sure.
Like
But
if you had to
it's like-
manipulate it so many times
Yeah.
to make a pattern.
Like, what am I even looking at here? What's the point of doing all this?
Right.
Is it this? It's not the pattern that I made it into. Like,
Right, but the whatever of this, the log of this, or the square root of that, or the square of this, are related to one another. So that means the originals were related. They just weren't related in a linear fashion.
humans in their linear wants, whatever.
Well, but part of it is that we have a lot of experience and a lot of knowledge about, well, what happens when we get a line? We know what R means. We know what R squared means. All those things, are helpful to us. Now, can you come up with a model that's a square root model? Yes. What does the R value mean then? Well, we would have to memorize, because it's not the same. You'd have to memorize, well, what does the r squared value mean in a square root, function? What does it mean if it's a logarithm? What does it mean? Ugh. It gets to be way too much. Okay? But I see what you're saying. After a while, you're like, you've jacked with this data so much to make it fit a line. And the question should become, can you do that with every set of data? And the answer is no. There's some data, it doesn't matter what you do to it, you're never going to make it into a line.
What if it just doesn't have correlation?
Yeah. Or what if it goes one direction and then goes another direction? Like if you have something where your original data looks like a parabola, you have no hope of ever making that into a line.
Just be happy with your parabolas.
Yeah, and go, yeah, it's not linearly related.
Yeah. Linear.
All right. So, how do you decide what to do? This table is called the ladder of powers.
Oh, that's cool.
So, if it appears that your data may be helped by re-expression, then try one. Honestly, I start with either square root or log. That's not your authors, that's me. And probably, unless I see something, probably log more often than anything else. And if that helps, but not enough, move one level down. And if you've gone too far, move up. Okay? So the 0 power, or excuse me, the 1 is the raw data. That's no change at all. Okay? If we do the 1/2, and the 1/2s and the zeros and the negative 1/2s, I kind of get them, but they kind of bug me too. I mean, I'll just be honest. It's like, okay, yes, but it's a little bit of a stretch. So the 1/2, that one makes sense because it's y to the 1/2 power. It's the square root of your, and again, although this is not the correct term to use, but I think we all understand it, the output variables, right? This isn't an input-output, but I still think of them as that because I've been trained in algebra forever. Okay, the 0, why is 0 log? I don't know. They were just trying to make it fit. So O for log, I suppose. Yeah. So notice here that the data can't, on the square root, if you've got counts, a lot of times the square root is helpful when you're re-expressing it. I don't know why, but it does happen a lot. So if you're, so you have your explanatory variable down here, and on your vertical axis you have the counts of things. A lot of times taking the square root of the counts will help.
What is the counts?
You're counting the frequency.
Oh.
Yeah, frequency, same thing as count.
So like the one on the front about the number of CUs?
Yeah. Yep. And notice because it's counts or frequency, it can't be negative, so you're okay taking the square root. Okay? For the log, again, it can't be negative data because you can't take the logarithm of a negative number. You don't need to know very much about logarithms for this class.
Thank you.
Right? But you do need to know that you can't take the log of a negative, or 0 for that matter.
Got it.
Okay? If any of the data contains zeros, you can add a small constant. This is one of those other ones that just feels like cheating. Andrew, you were saying that you were bothered by some of these, like you've done so much to it. Here, so it works, you add like 0.01 to everything and then take the log, because that way you don't have any zeros. I don't think there's any in your homework like that. You just need to be aware that that's something that can happen. This is helpful if your data is concave up. Does everybody know concave up?
Like this.
Yep. So if your data does like this, actually just this part, if your data is concave up, taking the logarithm, which is concave down, can flatten that out sometimes. The negative reciprocal square root, yikes. So there's a couple of things going on. This one's not very common. I have used it a couple of times when I was just getting desperate to make something work. I'm like, that's still not very linear, and so I've tried this one. The reason you put the negative in here is because then the direction of the relationship is still the same. You know, your positive direction or your negative direction is still the same. If you don't have that negative in there, it switches on you, which people tend to not like. Okay? Then you can also just do the negative reciprocal. Again, the change in signs helps you preserve direction. If the data includes zeros, you got to add a small constant again because you can't divide by 0. Again, I don't think I've ever seen one like that in your book, but I suppose it's possible. On the other hand, if going this way makes it worse, you can go this way, but there's not a whole lot you can do. You can take the square of the data values, that is y squared. So for things that are skewed left, or scatter plots that look like a square root graph, which makes sense. If it looks like a square root graph, squaring it should help. Right? That's what we did with the f-stop one at the beginning. Now, if none of those work,
Your turbine and your stuff isn't actually related at all.
you go to plan B.
This is plan B. I
Technical
thought we just
algorithms.
went through like.
Yeah, and that's what they called it. I'm like,
That's kind of cool. No?
it's all right. It's a little cheesy for me. Basically, what you do is try taking logs of your input, try taking log of your output, try taking log of both.
But like why?
To get it to look more like a line.
Well, like at that point, like
It's just too much.
like
No, it
just
happens.
go home.
Go home. You went to.
What happens if it's just not a line? Like it just does not want to be a line.
There's no relationship.
Data?
Yeah. So you're not going to be asked to re-express something that there's no way to make it better. There will be some times, and we're going to go through one like this later on, where you make it better, but it's still not great. And we'll talk about, well, what should we do with that if we were really trying to analyze it? We're going to look at one, I guess on Thursday, where we look at the length of an alligator compared to its weight. You'd like to be able to, because you can estimate how long an alligator is fairly accurately. Figuring out how heavy it is, that's a different story altogether. And we're going to find one where it's like, that's pretty bad. And we make it better, and you're like, that's still not great. What can we do to make it even better than that?
Maybe they're just not related.
They are. But that's another story.
They are if you just play with it long enough, right?
I mean, anything is related if you play with it long enough.
Sounds sus.
So here's the deal. I went ahead, I actually took this from the College Board course description. What is it that they expect you to know about this? So they expect you to be able to calculate a predicted response using a least squares regression line for a transformed data set. So in other words, if they transform the data set using one of these ways of re-expressing, they expect you to be able to put in an explanatory value and get out a predicted value. That's just the math. That's pretty easy. Okay. They also expect you to kind of know that once you have transformed data, hopefully it's more linear. That's what that whole thing says. Such as logarithm or squaring each value of the explanatory variable. What is evidence that it's better? This is the part where I'm like, okay, this is something you need to know. Increased randomness in residual plots after transformation of the data means that it's better than it was. And or movement of an R squared value closer to 1. That also offers evidence that it's better. Not that it's perfect, but that it's at least better than it was before.
Wait, why R squared and not R? Was that just arbitrary?
It could be either. It's easier to talk about R squared because R can be negative.
Right. Okay.
So yeah, you could do the absolute value of R is closer to 1.
That's a lot of work. So.
Right.
I feel like it's the same amount of work as squaring it.
It's actually less work.
Frequently R squared is given to you as part of the information, as part of the summary. Okay, any questions about that?
No. Ready.
Okay, just as a reminder, let's see, what have we got going on this week?
Quiz.
I feel like I have quiz every day. Would they be
We
that?
didn't have one today.
Yeah.
So quiz on chapter 8.
Oh my gosh, we don't have class tomorrow.
Pardon?
I said, oh my gosh, we don't have class tomorrow.
She's gonna miss
Yeah,
it.
tomorrow's Wednesday.
I think I'm skipping school tomorrow.
Oh, good for you.
Why?
I just can't make that decision.
Because my classes that I have tomorrow are Gov, Study Hall, Art, and Psych. And in Psych, we're watching a movie. And I don't know if we're